Today we're going to talk about analyzing conditional statements. A conditional statement is a statement whose basic form is if P then Q, or P then Q. P is the hypothesis and Q is the conclusion. You'll be using those words in science as well as in math. So if we consider a statement, all runners are athletes, the conditional form is the if-then form. If a person is a runner, then the person is an athlete. So we can make a conditional statement from a regular statement. If we have the statement 3 points are collinear if there is a line containing them, you would write the conditional form if there is a line containing the 3 points, then the points are collinear. Our first example is to just rewrite the conditional statement in an if-then form. So if you have the statement all whales are animals, you would rewrite it in a conditional form. If an animal is a whale, then it is a mammal. This is the if statement, the hypothesis. We can call that P, and the then statement or the conclusion, we can call that Q. If our second example, 3 points are collinear if there is a line containing them. So we basically have a form that we can write as a definition. So the statement is 3 points are collinear if there is a line containing them. The conditional form of that statement is if a line contains 3 points, then they are collinear. We could write that as if P then Q, or even shorter, if P then Q. Let's look at numbers 2 and 3 on rewriting the conditional statements in the if-then form. Let's look at number 2 to start with. Number 2 says 2x plus 7 equals 1. We can write that as a conditional statement as if x equals -3, then, oops, I did it backwards. Let's rewrite that. I don't like the color anyway. If 2x plus 7 equals 1, then x equals -3. Okay? So let's look at number 3. If n squared equals 81, then n equals 9. Please put your answer to question number 1 in the answer to box number 1 on the form when you finish. Here we have an additional statement. We have the conditional statement, if P then Q. We have the converse, that's kind of like the opposite, if Q then P. Please notice that P and Q are sentences, and if both of these are true, it means that you have a biconditional, which we'll talk about in a little bit. So if we have the conditional, if a parallelogram is a square, then it is a rectangle. The parallelogram is a square is Q, the rectangle is P, we write it if P then Q. The converse of that is if then reversed. If it is a rectangle, then a parallelogram is a square. We write it if Q then P. The inverse is if not Q, then if not P, then not Q, and the contrapositive is if not Q, then not P. So if the parallelogram is not a square, then it is not a rectangle. If the parallelogram is not a rectangle, then it is not a square. Please see video 2.2b to continue this section.